Good morning, everyone. As mentioned earlier, my name is Nicholas Metherall. I'm working with the Pacific community, and my background is in hydrology and environmental science, and my role is to bridge these areas of science into the work that we're doing on building Earth observation and GIS mapping products. And so we'll be sharing a bit about this later on, but I'm going to pass now to my colleague, Christmas, who will also give her introduction, and then we'll continue with the agenda here, presented here. So I'll pass back to you, Christmas.
Thank you, Nicholas. Hi, everyone again. So let me share my screen, but again, I think I couldn't share the screen, Nick.
Okay, I'll just stop sharing. Are you able to share now? Is it still?
Yes. Okay. So yeah, my name is Christmas UCHIYAMA, and so this is like our 9th day in Fiji. We just came from Raki province, and we've worked with the communities, collected some data, and had a nice engagement with the community there. So I just want to give a brief introduction on this project, and we're really happy that COG is co-hosting this modeling training. So for some introductions, so again, my name is Christmas UCHIYAMA, and I'll be co-moderating with Nicholas Materal. So we also have here Dr. Anish Singh and Dr. Chris Leong and Dr. Jun YASUMOTO. So I will try to make the training as manageable as possible. It's a little bit tricky to facilitate on-site and a hybrid training, like both on-site and with online participants, but we're really happy to see many people interested in this topic. But just a little bit to give a little bit of background, and I know my colleagues here will introduce more. But yeah, this is titled Co-Developing Nutrient Thresholds in Submarine Groundwater Discharge. And this project is funded by APN. And the main purpose is we would like to build the capacity of our local communities as well as our early career researchers here and people from the government. So, however, in this particular workshop, the main aim is to introduce the concept of submarine groundwater discharge. So that's the technical term we are looking for here. And of course, how this relates with land-based activities and the local culture and the practices in the coastal communities here in Fiji. And this is aligned again with, as I've said, with APN, the Asia Pacific Network for Global Change Research, which we are collaborating with the Research Institute for Nature. This is for the main purpose of enhancing scientific and technical capabilities, not only in Fiji, but beyond Fiji. So hopefully, I'm able to give a bit of introduction, and just to update everyone that we have here about 4 early career researchers in the room. And I think some other people are about to come in. So I think I'll probably just show you this slide now that you're seeing this groundwater resources in small islands. It's just a kind of framing. We all know this, and I'm sure a lot of people in this community know that there's always a problem in small islands because of the small area and low recharge rate, and also the vulnerability of the island to the impacts of climate change. Also, the institutional measures are also not so adequate. But the focus now here is how to keep the thresholds and how to keep the balance. So here you can see that the planetary boundaries has said in a lot of reports, also this has been cited, that it's important to safeguard groundwater because it's something that we could always rely on in small islands, freshwater, the groundwater. But because of intensification of agricultural activities, we have been reaching and to that red level of the nutrient flows. So this is one of the aim of the workshop, and that's why we wanted to promote the importance of understanding this connection between the nutrients and the submarine groundwater discharge, and as well as reconciling with local activities, with local people, and helping them to find the balance between sustainability and between agriculture development. So yeah, this is part of a whole project, and as I've said, this particular modeling training is for those who are interested in the MODFLOW and in the way we could present data and the way we could customize models depending on an island setting. So I hope that our participants online here would have a lot of questions and would enjoy this training session. Yeah, and I just want to move on to the next part, just to introduce our colleague here who can give our opening remarks. I'll pass it to Dr. Anish.
Thank you, Christmas. Good morning, everyone. It's a great pleasure to join you today and extend a very warm welcome on behalf of the Asia Pacific Network for Global Trade Research, or APN for short. I'm the Scientific Planning Group member for Fiji and also the chair of the APN Pacific Sub-Regional Committee. And I'm honored to be here with you, colleagues, partners, participants who share a common commitment to advancing scientific knowledge and capacity in our region. The workshop is a very important part of APN-funded project, which Chris leads, and it reflects APN's vision of fostering collaborative research, capacity development, and knowledge exchange across borders. The Asia-Pacific region is one of the most climate and disaster vulnerable regions in the world, as you know. And it is through initiatives like this today that we build tools, skills, and partnerships that are needed to understand, anticipate, and respond to complex environmental changes and issues. Modeling, as you all know, is more than just a technical exercise. It helps us translate data into insights, insights into decisions, and decisions into action. The work you will be engaging in over the course of this workshop will not only strengthen your scientific capacity, but also support evidence-based policies and practices that benefit communities, economies, and ecosystems in the Asia-Pacific region. I'd like to thank the project leads and the organizing team, Christmas, for bringing us together and to acknowledge Asia-Pacific Network's continued support in enabling such vital collaboration, especially for us in the Pacific region. Most importantly, I commend you all who are joining today for your participation and expertise you bring into this workshop. I encourage you to share openly, learn from one another, and build lasting connections. Together, we can continue to shape a region that is resilient, informed, and ready for the challenges ahead. So with that, I wish you a very successful and productive workshop. Thank you, Chris.
Thank you, Anish. Yeah, it's really good to connect with you again today in Fiji, and to also provide that encouraging message to all the researchers out there. So we move on to some introductory part of the session. And now I give the floor to two of our speakers who would be providing the introductory concepts about modeling and about hydrology. So I'd like to give the floor now to Dr. Chris Leong from the Research Institute of Humanity and Nature, and as well as to Dr. Jun YASUMOTO from the Research Institute of Humanity and Nature, as well as the University of the Ryukyus.
Okay. Thank you very much. I need to.
It should work now, Chris.
Okay now. Testing.
It's working
Yeah.
this time.
It's okay.
I
now.
mute.
No, now you mute, but it was working. It's all good, Chris. And mute and you're gonna be good.
Turn on mine, eh?
Yes.
Okay. Okay, cool. Can everyone hear me?
Yes.
Yes.
I'm not sure whether.
Yes, can hear you properly.
Chris, should I just use your?
Can you hear Chris? Hello, can you hear us? Okay.
Yes, we
Yeah,
can hear.
Okay, cool.
The problem like battery and there's no.
Okay. Shall I just use yours?
Just a moment, everyone.
Testing.
It's working fine, Chris. You can
Okay.
proceed.
Okay, thank you very much. For all the participants that have come in this morning and are walking in right now in the room. Just a brief idea on why we wanted to do this. A couple of years back, we set up a questionnaire around the South Pacific, and we found out there were specialists that they did not have much modeling experiences. So under this COG water resources platform with the Pearl and Nicholas, we decided to set up a modeling training for the Pacific Islanders. And I'm grateful that my colleague, Dr. Fatima, has joined us today to present her modeling experiences, yes, with specifically with MODFLOW 6. And just why we chose MODFLOW 6 is because we noticed that Pacific Islanders, they tend to outsource from overseas. So what we want to do is have trained the Pacific Islanders to have the opportunity and to develop their own modeling skills. So that is why we are here today. And just an overview of we will run two sorts of modeling. One is the GUI, where you will use the Model Muse interface. And I hope that you have all been able to download the software MODFLOW 6 and the GUI, because you can't read code. The code is too long, and the GUI also, you need practice. So you need to have your laptops on and be prepared. So for this exercise, we'll start with the GUI because it's a little bit simpler. And in the next training, we will use coding. So I'm not sure how proficient people are in coding, but we'll try and tone it down the next time we meet. So I think before my presentation, I'll let Professor Yasumoto give a background on MODFLOW 6. So MODFLOW 6, Professor Yasumoto and we trained with the USGS, United States Geological Survey in Minnesota. Yeah, we have a fair idea of how this works. But mind you, we're also learning as we go along. Now I hand it over to Professor Yasumoto to make his presentation.
Hello, everyone. I'm Jun Yasumoto. I'm working for Research Institute for Humanity and Nature, which located in Kyoto, Japan. I'm a project leader of the LINKAGE Project. Welcome and thank you for joining this workshop. Today, I will introduce MODFLOW and demonstrate how it used for groundwater modeling, especially in coastal and island environment. The internet connection is very slow. My voice may be hard to hear at times. Please let me know if that happens. So let me start by highlighting some of the key groundwater challenges in Fiji. In many rural and pre-urban areas, people depend heavily on wells and boreholes for their daily water needs. But with climate change and growing population, groundwater is becoming more valuable, both to depletion and to contaminations. And regions such as Bab area face double challenges. They suffer from drought linked to El Nino, and at the same time, they are also hit by flood from tropical cyclones. And groundwater also flow into the sea as submarine groundwater discharge. This process is very important for coastal water quality and coastal reef ecosystem, but it can also carry land-based contamination into the ocean, carrying risk for both the environment and communities. So groundwater in Fiji is not only vital water supply for people, but also a key factor linking the land and the sea. And MODFLOW is a groundwater flow simulator. It can represent three-dimensional groundwater flow under both steady state and transit conditions. In short, it's the most widely used tool for groundwater modeling worldwide. As you will see, MODFLOW has been extended to be much more. MODFLOW is based on the groundwater flow equation. It's used control volume in different methods to approximately groundwater flow in a grid system. This is a mathematical foundation of the model. MODFLOW has traditionally used a 7-point structured equation for groundwater flow. We now use an unstructured form of the finite difference equation in MODFLOW, as it offers more flexibility for special discretization. MODFLOW is a modular. Each package handles specific processes like wells, rivers, drains, recharge, or evapotranspiration. We can turn the package on or off depending on what we need to simulate. Okay. The package concept in MODFLOW has been a nice way to compartmentalize the effect of boundary condition or stress on the aquifer. Packages were designed to be independent and act solely as a stress on the aquifer. Over time, package became much more complex, oftentimes representing through hydrologic processes such as stream flow. Furthermore, it became necessary for packages to communicate with other packages, requiring new writing that that was never part of the original MODFLOW structure. Just one. MODFLOW was first developed nearly 40 years ago. It's called community models because it's modular, teachable, and widely shared. Stable finding has helped MODFLOW remain reliable and accessible. Since 1984, MODFLOW has several versions. Today, MODFLOW 6 is a core version, but there are also many variant such as CWAT for solute and heat transport, or CFP for karst and conduit flow. No, sorry. This slide shows the ecosystem of code around MODFLOW. At the center are the core principles: teachable, documented, reliable, robust, efficient, extendable, and portable. Surrounding it are many tools and extensions for solute transport, reactive transport, subsidence, surface water, parameter estimation, and more. Together, they make MODFLOW not just a single model, but a platform. MODFLOW can be applied at many scales, from local site to regional, national, and even global studies. For our workshop, we will focus on island and coastal aquifer applications. And I'd like to show some examples. This example shows an island situation. MODFLOW allows us to examine how freshwater lanes form and respond to pumping, recharge, and sea level rise. A spin-up simulation helps the model reach equilibrium condition before applying scenarios. This is useful when we want to study long-term change in groundwater. Here is a scenario of sea level rise, 1 meter in 100 years. MODFLOW allows us to impose change boundary condition to study future impact. As you can see, these movies. Coastal aquifer models help us understand the balance between freshwater inflow and seawater boundaries. These simulations are critical for small islands like Fiji. To simulate sea level rise, we adjust recharge and boundary condition in MODFLOW. For example, recharge can decrease with higher sea level, and general head boundary can shift accordingly, like this. So by applying these boundary conditions, we can run long-term simulation and visualize the effect of rising sea level on island aquifers. Okay. Thank you for your attention, Pinaka. I hope this workshop helped you better understanding groundwater modeling and its application for island sustainability. The practical application will be explained in detail by Dr. Chris Leon. Thank you very much for your attention. Oh, yeah.
She's clinicky. Thank you. Thank you.
Bruce, just while you're sharing your screen, I had a question just while you're setting up. You listed, Professor Yasumoto, you listed that there's different extensions and different modules for surface water, for example, to connect to MODFLOW 6. And you listed HECRAS as the model, but
Great.
can you also
Thank you
use
very much.
SWOT?
Let's dive into our modeling exercises. And as I said before, we split the modeling because there's two approaches to MODFLOW 6. So just a very short recap on what Professor Yasumoto said. MODFLOW 6 is the combination of all different types of variants. So before it was MODFLOW 2005. You had to separate different files, so which means that you had to create outputs of one variant to input into the next one, into the next variant. So that was kind of difficult, and especially when there's compatibility issues. So now MODFLOW 6 has been developed. Everything is under one roof now, so which makes it kind of a little bit easier. And I think with my approach, I use the code, and I use the coding thing. So I hope that you are able to write Python. MODFLOW 6 is compatible with Python. So if you don't write code, it's not a problem because you can also use the GUI. The only difference with the GUI is that it's not reproducible. You cannot apply it somewhere else. You have to change the whole thing. With the code, it's kind of easy. Just make the arrangements in the parameters and you can change it. So that should be simple. Here, my main presentation now is to give you an idea of how the code is going to be written before and an example of how much you can do with MODFLOW from the very basic implementations to the complex 3D simulations. But in the next phase after this, my colleague will introduce with the GUI. So please let me start with our presentation. So as Christmas has said, that we are a team that's more focused on submarine groundwater discharge. So in the literature, we in the Pacific region, there's only, I think, about two that we recognized doing this study. One is our study that we're doing in Rakiraki, Fiji, and the other is a team of scientists from Australia. They're working on the Great Barrier Reef. So we've seen similar impacts of submarine groundwater discharge towards the oceans that are killing the coral reefs. So again, you can see that you are probably wondering why are hydrologists focused on coral reefs? And we should think that we should know that water is what connects the land and the sea. So it's what can I say? It's we need to take the full system, the full dynamic system. We can only consider one section. So my title today is The Insights into a Submarine Groundwater Discharge. as a major nutrient pathway for phosphate accumulating, affecting coral reefs. So here I'm going to give an idea of how you can use MODFLOW 6 to model your impacts, so you can make your water resources management arrangements. And also just on the side, if you can just type in, if anyone just say like, oh, I know coding or something like that. So if you know coding, just type yes or something like that, huh? So we can have a follow-up on it. What we do is we try and extract phosphate from sediments in around the world. So this is Sekisei Lagoon in the Japanese southern islands of Japan, and here the corals are they're practically dead in some areas. There's just all sand, and we think that when we're looking at white sand and the beaches, we think like, oh, that's so beautiful, you know. But actually, if you don't have corals in the system in that sandy area, the patch is practically dead. Yeah. So here all these yellow points are showing different areas where we will dive in to collect the coral samples. So we are hydrologists, and why are we collecting coral samples? The question. So I'll explain this in the next few slides. So our island and our study area is Kuroshima. This is down the southern parts of the Sekisei Lagoon. We also work in Indonesia and now in Raki-Raki. So Kuroshima Island here is a population of about 200 people. They have more cows than the population itself. So about 3,000 plus cows. The reason is because this is Japan has the most expensive beef in the world, Wagyu. So they breed these cows down there. These are the most expensive cows down there. So, and their groundwater system is contaminated. So since 1970s, they have drawn water resources from Iriomote Island, the next one that's close to it. And here we want to understand the terrestrial phosphorus mixing with the exchangeable phosphate in seawater. So the idea here is we noticed around Kuroshima when we were looking at their coral reefs, it was dying out. And so we collected all the samples and we're trying to figure out, okay, how can we think about reducing the amount of excess nutrients into the ocean. Yeah, we need to figure that out. How can we decide that? And one way we can do that is to model, use a model to estimate how much we can put on land. So if you look at the diagram, you see, okay, there's domestic waste, that is an agriculture and livestock. This is a typical setting for us Pacific Islanders. So rivers and groundwater are two major pathways that transport nutrients into the ocean. Nutrients are okay. The corals and the living creatures in the sea, they like to have those nutrients, but too much of it is not good. They die out. And here you have the river water, which everyone understands and knows because we see it a lot. But the groundwater is the one that's difficult. So we looked at the literature in the South Pacific islands, and I don't think there's any. There was only one study in American Samoa that looked at submarine groundwater discharge. The reason why we are looking at submarine groundwater discharge, the submarine parts, is because of the impact that it had. We think that the impact of the groundwater discharge on coral reefs is more dangerous than the river, because the river has a quick discharge. So when it's overland flow, it just goes straight into the river and out into the ocean. With submarine groundwater discharge, what happens is the phosphorus sinks into the groundwater sources, And there's a delay time. So in groundwater, you have this residence time. So it takes a bit of time for the groundwater to be discharged. So we think that because of this complex mixture of time and salinity in the groundwater sources underground, the inorganic compound has been created. So when you put it on the land, it becomes organic, but when it goes down, it becomes inorganic. And this is the problem. When it goes into the ocean, it starts to impact the growth of juvenile corals. Yeah, so that is the reason why we need to understand how much terrestrial load we need. So from this, we know now that, okay, at this certain growth of juvenile corals, they die. So we can work our way back. And that we use MODFLOW to estimate like how we can at least give some agriculture or protection advice. So the idea is you load terrestrial phosphorus on the land, and then it goes into sip into the converted exchangeable phosphate in the seawater. And we have found now the threshold. Let's say the threshold is about 0.5 micrometer. And from this, if you look at our small graph on the left-hand side, then we can know how much load we can get from the exchangeable phosphate, the plotting on that curve. So here, just an idea of just a picture of what is happening. The study by YASUMOTO et al. Is one. Our team there is one that we think that stands out in this very focused study of nutrient access towards coral reefs. Then we could use this as this could be an indicator for terrestrial load to help our agriculture and fisheries connect. This could be one way we could connect interdisciplinary ministries or transdisciplinary objectives. So our work is to model the groundwater flow towards the ocean. So the next part is we are pre-processing. This is important. I think it'll be good if you have knowledge in georeferencing. I think ArcGIS and QGIS. It's a good tool to have in your arsenal. So you probably you can do this in MODFLOW, but I think it would be better if you prepared it in QGIS or ArcGIS. It's a little bit more simple. Right? So the idea is here you can create your own grids. And there's resources on YouTube that you can look at and follow along. So here is one area that we noticed people tend to forget, and I also happen to come across this myself. I forget to resample. So here we are trying to fit the grid perfectly. If you look on the edge, it's missing. So there's some spaces missing on the edge, and these create problems because the MODFLOW is very sensitive to your grid setup. These are setting up the dimensions. So this is also developed from MODFLOW. This is just setting the bathymetry and the elevations. So depending on how you want to do your model setup, our team is trying to develop a systematic way for Pacific Island countries where they input different parameters and try to find out the accuracy because Pacific Islanders hardly have data. So we're trying to put in all different parameters where we can see like, oh, you only need these 2 or these 3 to get at least good results. We don't need the whole set. And one thing you can do in modeling with MODFLOW 6 is you discretize the layers. So you can have just a single layer, just one layer setup, but here you can discretize it to have a better flow throughout the cells. It depends on your geological information. You can make an assumption of me. And the next slide is just showing your, you need to have some, what you call, observe the setup. For this is to validate your results. So here we have our 2 wells, and from this we can draw our validation at the end of the simulations. Next ones, what we need to do is the setting up of the initial conditions. So we need to run equilibrium. We need to find equilibrium before we actually run the model, because the as you start off the model, it's trying to fix itself. And you need to, if you look at the graph, there's a steep drop and then it starts to stabilize. So you depending on your setup, you can run a stabilized, but you only want to take the end part, because these are the information from the end of your model. The data from the end of your simulations is the beginning of your real model, your model setup. So here because we know, now we're setting up our initial conditions, and we want to set up parameters. Common parameters are the hydraulic conductivity, the specific yield, and storage and recharge that you could use. Depending on your area, you could set up a range. So here what we did is we set up a range, and we just loop through it for every combination. So it may take some time. So depending on your computer setup. So mine takes about 7 hours or something to run through all these combinations. We are trying to find the best parameter combinations to use as our initial conditions. And MODFLOW 6 packages are there: the TDIS, the iterative model discretization, initial condition setup, saltwater intrusion, storage, recharge, general head boundaries, and drainage, and the output control. So I think Fatima will explain this in detail in her slides. These are the calibration results. So we are trying to here fit, like graph fit. So after we calibrated, then we found that around 400 is the hydraulic conductivity good, and the specific yield and specific storage are just about the same, and the recharge is about very low. And with the same initial conditions, we run it. We rerun the same thing. So then when we rerun it, then we can start playing around now. Now that we've set up our we have stabilized the model, we can set up now what we want to do, like our main parameters. So here, if you look now, I've met HK is 129, but you said like, hey, HK is 400 before, but that is the calibration. Now we are actually using the values. How did I get this HK 129? This can be some mathematical equations. You can use tides to calculate the hydraulic conductivity going through, because from the ocean, when it's high tide, it pushes the freshwater inland. So in the wells, if you remember, I had 2 points on the ground where our wells were. So we can monitor the heads, the hydraulic head in the well going up and down. So we know the change in tide pushing those elevations in the well. We can tell how much the hydraulic conductivity is. And this is just the land thickness simulation of how our length ranges. And here, I think you need to, if you are using this sort of approach, then I think you need to do a geophysical resistivity survey. Yeah? We go into the field and things, so you can do this. I think in Fiji, the Mineral Resources Department, they do this a lot. So if they have that, then they just need to run their land thickness with this type of MODFLOW and just compare it, just to be same. So here this is both low tide and high tide. As we know, when it's low tide, the groundwater lenses start to thicken up, and when it's high tide, it pushes up into the land. And here on the coastline is our points, major points where we have groundwater outflow. So the red one shows high tide, where the positions are getting out, where the groundwater discharge is made during low tide. And the blue one show during high tide. So it makes sense when it's low tide, because the water level drops out, the distance of groundwater discharge is further out into the ocean. And approximately this is about 200 meters. So we usually in real situations, when we go to the beach, we see the water coming out of the sand. So we only think that it's there, but it's actually further deeper out into the reefs. So that's why this is, we think that it's submarine groundwater is very destructive to coral reefs, because they actually just get discharged straight out onto the reef. And just to confirm, we checked out our resistivity survey into the ocean, and here's a small graph that we did, and just to make sure, I think it's about 3 to 5 meters thick during low tide at the ends, at the edge of the coast. And so now we look at the major outflow. So everywhere on the island, there's discharge. There's no doubt about it. But we want to look at the major discharge points. So we set up the code in MODFLOW to pick out where are the major discharges happening. So if you can look, it's quite interesting that all the major discharges on the right side. And if you look at the phosphorus content of the yellow points, you see the major points in the study area is along the right side. It's also they are like is it complementary or something like that? Yeah. So now here we can find out our zones, because we know, okay, so it's about 200 meters out. Then we can draw a buffer from the coast. Yeah, and then say like, okay, within this area, this is the amount that's been affected by this certain amount. So if you look at the idea is for every coral sample point that you have, we take a radius around it and say like, okay, with every suspended load, we can find the average. And that's how we match it. We match it to find that threshold. Like something like this. So we can actually point to where the terrestrial threshold is. So this is incomplete. I'm still working on it at the moment. But this is an idea of what we have. So if we can back again here, we can get the EPS and the average load, and you can plot it like that, and we can find something for our water resources management, like a preliminary assessment. Yeah, so just the key preliminary takeaways. We know that the phosphorus and the groundwater, submarine groundwater discharge is quite impacting the coastal areas. There's a little bit more that we are doing on. We are the phosphorus team. Our nitrogen team is also working to confirm that. And this is a first order approach. So Pacific Islanders, when we doing our modeling, please make it as simple as possible. Do not try to increase the complexity of something that is already complex. And it's important for our water resources management and coastal protection. And there are other things that you could do, but this is only for thing. So depending on your ministries, you would probably want to have water resources management for extraction, groundwater extraction and stuff like that. And I think that's my end. And I hope to meet you next year, maybe during the next presentation, where I will outlay the code and we can work together. So please don't be alarmed. Just type there that I know coding or something like that, and we can look at it. And I think artificial intelligence has really come in handy, especially for us Pacific Islanders. So we will use AI to help everyone understand easily. So if you don't know any coding when we meet next time, it's not a problem because we will try to integrate the AI into it. So thank you very much, and I will pass it on to Christmas to introduce Dr. Fatima.
Okay, thanks, Chris, and thanks to Dr. YASUMOTO for those introductory concepts. I hope everyone is okay. So what we have in our program is we'll have a break, but while we do that, I'm going to take all the questions here from the participants on site. And also, I hope all the participants online can still get engaged, and please continue to answer the question, can you do some coding? Just please type yes or no. And also, if you have any questions from the previous talks, please feel free to put it on the chat box. Meanwhile, let's have a break for about 10 minutes, and we'll welcome Fatima at about 10:10 Fijian time. Thank you. See you again later. Hello, everyone. Hi. Thanks for waiting. We are just about to start again. And from our group on site, we've gathered one question. That question is asked by one of the representatives from the Mineral Resources Department of Fiji. And that's about whether MODFLOW can be used for mineral-related investigations. How about you, Nick? Let me check just the screen. Another question is that a question from Nick, given that this is a modular software that can be combined with other packages, extensions. For surface water, you listed HEC-CRAS as compatible, but not SWOT models. Does this mean that SWOT is not compatible as a surface water module for MODFLOW 6? And I think there we have it. We have two questions and more. Another question is about bathymetry. So do you do this separately and insert this into MODFLOW, or MODFLOW generates it from cross sections? This is from Juliana. So again, any other questions? You could just type it in the chat box, and then I think we could have chance later to discuss after the presentation of Fatima. Would that be okay to go forward, everyone? Yeah, that's all the questions for now. We have 3 questions, and now if Fatima is ready, Fatima, I'd like to give the floor to you to introduce yourself and to talk about your topic.
Yes. Hello, everyone.
Over to
Can you
you,
hear me?
Fatima.
Fine. How are you doing all? I hope you are all doing well. Can you hear me properly?
Yes, thank you.
Yes. Okay. So this is Dr. Fatima from Algeria, and currently I'm a researcher in groundwater modeling and machine learning at University of Doha in Qatar, University for Science and Technology. And thank you so for all my colleague in this workshop, and thanks for the participants for joining us today. Thanks for giving me this the time to show you, let's say, a practical example of modeling using MODFLOW, and talk a little bit about my experience using MODFLOW for modeling interactions between groundwater and surface water. Are you ready all? I want to just ask you, first of all, about the software. Did you install the software or no? Can you please write yes, yes, or no? And before going through the example, I just want to go through some basic informations about modeling framework. So as presented before by my colleague in the workshop about MODFLOW, the equation that used by the software, I will just go directly to the modeling framework without repeating the other notions or informations. So when we talk about the modeling framework or which steps we go through when we will model the groundwater, let's say for quality or for quantity study, we first have should pass by conceptual model. What do we mean by conceptual model? It's like building our data, filter it, analyze it, and we will, let's say, set which data will insert our model. We can set, for example, for the first point, the number of the layers, the thickness of the layer, the hydraulic conductivity, how many wells we'll have in our model, which packages we'll have. For example, if we have any river that pass by our study area, what is the, let's say, precipitation or the recharge? Do we have natural recharge? What's the rate for this recharge? Do we have any artificial recharge? Also, what's the rate? We need for sure for the wells. The wells or the pumping or extraction from our groundwater is very important, so we need the rate. We can have some other, let's say, packages according or based on our let's say system or our groundwater and how complex it is. So this is the first step, which is the conceptual model. Sorry. The second step is using the grids, and generally based on choosing the grids on how data we have and let's say our area. Generally we go through, let's say, a process or the idea that having at least one point or one well or measurement point in every grid. This is the minimum, okay? The third step is inputting boundary conditions. So we can set, for example, as boundary conditions when we have in the sea, when we have in some other inflow from other groundwater, adjacent to groundwater, and so on. We see, this is just briefly the steps, then we'll go one by one in our example. The fourth step is starting with the steady state. What do we mean by the steady state? I can just go back here. So the steady state is when the groundwater conditions are set as there is no change during the time. So this item in our equation will be equal to 0. The derivative, let's say derivative of the hydraulic head by time is 0. While the second model, let's say, or phase of a modeling is the transient, where we study more the response of our groundwater to the stress. Saying stress, we mean by pumping or recharge variation, specifically based for or because of the climate change, specifically nowadays. Okay, so this is for the transient model and the steady state. And then we can also use in MODFLOW 6 going through future projections. For example, using we can insert, for example, the recharge based on any models for climate change like SMEIP 6 or SMEIP 5. This is for the framework and the steps that we will pass by when we will go for modeling our groundwater. Now we'll go just for a quick interface tour for our interface. And so you have let's say the tour image in the handout that was sent to you before the workshop, but I will go through it again. Let me just share again my screen. Give me a few seconds, please. So this is the interface, what we call model muse. And here we can say that just a model opened here. So we can pass by the main menu here. In file, we can import many kinds of, let's say, files. I want just to mention again, as Dr. Chris mentioned before, that it's very good to use or to prepare your data as GIS files, shape files. So it's better if we are using the interface and not the coding. So for example, here the study area, I prepared it already on GIS, for example, QGIS or ArcGIS. Then I import it here as a shapefile, which is, let's say, a facility in modeling using MODFLOW and this interface. So we can import many kinds of files, shapefile, we have grids, we have even a digital elevation model, image, and so on. Then I will pass through the most important one. In grid, we can go through generating grids. We can even switch to, let's say, more precise grid, like, for example, DISV. I will just show you an example. For example, I have the river here, and as I was interested about studying the interaction between surface water and the groundwater, I just choose grids that are smaller and to have more precision for this area. This is an addition thing in MODFLOW 6. We just go back here. So this is for the grid part. It's mainly about the grids. Then we have the data, and here we can edit the data mainly. For example, if I press, I will just go back slowly. If I press edit data set, I will have some optional data that I can manage. This is when we have the model. So we can go to hydrology, and we can here set the cell type, the type of the layer. We can set the hydraulic conductivity through three dimension. We can set also the MODFLOW initial head. So for the MODFLOW initial head, we can just set it as a formula, as a value, or even as a shapefile. For example, in my case, I just set it as a shapefile. We have the specific head, the specific storage, and so on. We have also the layer definition. So we have here, let's say, the thickness of the layer, mentioned here with a formula. If we go to user define, there are let's say, the shapefile that I imported in my model. This is for the data set. We go to objects, it's for drawing in the model mainly, but we don't do this too much. Like usually we just import the ready data from GIS or any kind of GIS software. And for view, this is just for the view. We can see here the view is just to change what to show exactly, if I want to show the grids or no, and so on, just mainly just for the view. And I will go to the model. Here it's an important thing. So we can edit the georeference. We use which reference or georeference parameters we have. And here we mention, or we can find the MODFLOW packages and programs. If I press here, give me just, sorry, the model is just blocking a little bit. Few seconds, please. Okay, so here we can see all the packages. So we'll go back, we can press on model and MODFLOW packages and programs, and we can find all the packages that is possible for using. So we have the first one, NPF, which is mainly used for the flow. And then we can have the fast one. So the fast is more for, this is for the storage, that's okay. And we have here the constant head. Generally, we use it when we have limits with the sea. We have the recharge. So we can set the recharge, for example, from precipitation. We have wells. And we have some others here, like when we have lake, when we have any, like when we want to study the saturated and unsaturated zone. If you want to go through any, like, let's say, multi-aquifers. So MODFLOW 6 can model many aquifers at the same time. We have evapotranspiration. So Chris also passed through this, so I will go quickly, and during our practical example, we'll just come back to this again. And for the solver, so it will be the iterative model solution. This is for the packages. And then this is the layer groups. We set this generally in the beginning. We have the model flow time. Also, for example, this is only for the transient. So I set many periods. I have many periods. My unit was per seconds. So all the units are, all the time is counted by seconds. And then we have output. We can just, yeah, this is the most important in this part. And then here we select the model. So with this interface, we can pass by using MODFLOW 6 or any other, let's say, version of MODFLOW. We have, for example, 25 and other, even for fast, for quality, geochemical quality, sorry. And we have, for example, well footprint, when we want just to, let's say, study the response or the effect of a well or one pumping point in the area that we want to put. Is it okay? If you are following me, please can you write one so I can pass to the other part or the next part? Just please press or type one, please. Thank you, Julia. Thank you, everyone. Okay, so this was just a tour for the main menu, and just for the view. So we have, this is the front view. Can I write? Give me just. Yeah, so this is the main view. This is the 3D one. Here what? Okay. So here we can use some, let's say if I want to add any boundary condition, or we can draw here, but I said that we rarely do this. This is also just for the grid. Okay, this one is important. This is when we press to, let's say, run the model, this one. This is for running. And we have these two options also, or parameters or items, which are important. So I can just hide or unhide, let's say, any drawing here or any package from here or any object. So for example, I go to MODFLOW features and I just hide the well. Okay, this is just more organized. These are all the wells, for example, I have. I just can press and see all of them. So this is only for hiding and unhiding. And now we can just go to the colorful one next to it to, let's say, see the results or any other, let's say, parameters. For example, we can go to contours. And I go, for example, for water table for a period. And here I have, let me check and hide the wells. And here I have my results. We can just show them as iso-piezo lines, or we can also have, let's say, a colorful map. Sorry, so we just go to color grid and we press this. And it will be in this guide. So that's mainly all the necessary things here. We can go now to our model. So the model will be really basic. Let's just to be familiar with more familiar with creating model. And maybe in the next workshops, if we'll have the opportunity, we can go to more complex models. Okay, please, did you install? Do you have the software? Let's type yes, please. Do you have the software? Do you have any issues to install the software? Very good, John. Thank you. Okay. Okay, great. So I will start again. Few seconds, please. So let's just open Model Muse. When we'll open it, we'll have this window. You just press on it. And you can have beside the handout, okay? Do you have the manual and the handout? Do you need any version in the Zoom chat? I can send it if you need. Okay, we can start. So here we will go to create model, create a new MODFLOW. So as I said, first is more for, let's say, geochemical or more for quality. So we'll go just for simple model today. We're just running a very simple model. I will press on create a new model and I will press next. So for the model description, we'll just type the name. For example, we'll say model 1. And then we have down, we have the starting time. Let's keep it the same. We have the simulation starting time. And then when coming to projection type, we have two options. We have a PCHS, which mainly have code for, which is, let's say, a numerical code. We have, for example, UTM zone 33N. The code is 32633. And when we don't have, let's say, a projection or where it's not covered by EPSG, we go to the second option, which is sorry. Select the option. I think this is a. Sorry, just Nicholas and select the option. Yes, exactly. That's it. So we are just working with MODFLOW 6. So for example, for our study, we can go to Fiji code. So it's 4326. So we can type here 4326. And let's keep the units as meters and seconds. And we press on next. And here we'll have the initial grid. So we'll have grid, sorry, and we'll have a number of layers, of rows, and of columns. So we'll have our, let's say, steady area with a number of rows, or with the grids, number of rows and columns and layers. So we'll keep, let's follow the same items or parameters mentioned in the handout, just we have small errors to correct. So we'll go to 15 rows and 15 columns and 3 layers. So I will set 15, and we'll keep 3 layers. We can go for column width of 150 and 200. This is when we will set the model directly, but in case that you will, let's say, import the shape file, you will just open it, then import the shape file. At the end, I can show you briefly or quickly, if we have enough time, how we can do this. Okay, for the, let's say, the elevation or the thickness of the layers, we start from the model top, then in 2 meters below we have, 20 meters below we have the upper aquifer, then in 30 meters we have the second layer, and in 45 we have, we have the third one. Everyone is with me, please can you type 2 in case you are following me. Great. Please, if you have any question, just type it so we can answer at the end. And we'll press on finish. Just sharing again. Yes. You will have this window with the shape that we set parameters for. Okay. Let's continue now for time properties. So we are setting the model only for the steady state, one stress period. So we'll go, if you remember where to find the time, it's always here. MODFLOW time. Again, we go to model, MODFLOW time, and we have the time in here. So let's keep it the same. In case we need to add any other, let's say, periods, we just go here and press. It will be the transient normally, but we will go only for the steady state. So let's stop here. I'll press OK and we'll continue. Now we go to the aquifer type. Let's say if it's, let's say, confined and unconfined, or convertible in case there are, let's say, switch between confined and unconfined. So we go to dataset, remember, from dataset, edit dataset, and here we find the characteristics. So we have the hydraulic conductivity, the initial head, the cell type, and so on. Are you with me? Let's type 3 if we are in the layers parameters, please. Okay. So for anyone who is late, I will go again, mod data, edit data set, and we go here. So I will continue. We go to cell type. Here, you will find default value, which is 0. We go to edit formula, and here we will use formula, or let's say kind of equations. We can go to case. Actually, you can do this manually and go for everyone and set in if it's confined or unconfined. But let's do this using logic equation function, sorry. So we go to functions, we go to logic, and we press case. And we continue now. So we will set that the first layer is unconfined, then we have confined and confined. So for the layer that is unconfined, we press 1. Just we need to mention that the parameter is layer. And then we press, we'll mention 1 for the first layer. Second layer is 0, and the third one is 0. To confirm that the, let's say the function is well written, you will have it here on the top. If there is any mistake, you won't have the formula on the top. Okay, we can continue. We press OK and apply. Let's continue. If you have any issue, just stop me, please. Now we'll go to the hydraulic conductivity. So just quick resume, we go through grids and parameters of layers, then we go to hydraulic conductivity. From where we will set the hydraulic conductivity, it's always from data, edit data sets, and we go to KX, KY, and KZ. So we go to edit formula, and we can here set a direct value, or if we want to use any, let's say, difference between Kx, let's say the system will be anisotrope, so we'll have a value of hydraulic conductivity for the first layer, one for the second layer, and one for the third layer. In this case, we prefer to use, let's say, the function. So we'll use always case here, and it will be Kx. So layer. The value is mentioned already in the handout, so we'll just copy it to keep the same. Same values. I will copy it here for you, so you can just pick the values directly. Okay, and it's showed on the top also. And we'll press apply. This is for Kx. Let's go for Ky. We'll put that, for example, it's Kx per 5. And for the Kz, we'll have another different values. So this will be the values for Kz. I will repeat, if we don't have any change between the layers, which is rare, generally we have the difference, we just let's mention one value. So for KZ, we'll mention the one. Please don't forget to mention or to press apply. There is a mistake here, so it's not, well, you see when there is a mistake, it's not shown on the top. So KZ, edit, and then we'll use the values. Are you with me? Let's type 4, right? Please type 4 if you are with me. So the second value, the first one I mentioned in the chat is for KX. Then KY is KX per. Yes, thank you so much, Nicola. For the others, is it okay for the hydraulic conductivity? If I want to see if it's really, let's say, correctly set it, we go here and we can just press the KX and we see the difference that it's set in different one. I will repeat how we can see this. I see only 1, 4. What about the others? Should I repeat for you? Should I repeat? Do you have any question? Yes, okay, I will repeat for how setting the hydraulic conductivity. Okay, so I will say again. So we go to data, edit data sets, and we go to KX. I said in my model, I want to set different values of hydraulic conductivity for the 3 layers. So I will press on edit formula. And in this case, I will go on the right. We have data sets now. We go to functions. I need a function. I go to function and then to logical. I press case B and then I will write layer because I'm mentioning this for layers. This is the first value for the first layer, second value for the second one, and for the third one. I send already the values directly in the chat, and you can find it in the handout. Is it okay? Can we just type again 4 if we did, or we input the hydraulic conductivity, please? Okay, sorry, yes, okay. I will give you more times. So for Christmas, in which step you are?
Fatima, we're still at step 3, I think. Yeah. So just give us a
Okay.
few moments.
Yes, no problem.
Thank you.
Yes, John, yes. So I mentioned that KX, this is the value. Then I think not all persons here, participants have the handout. So KX is this. Let me just write in the discussion. And then KY equal KZ 5. And then we have KZ. This is the value. Yes, exactly. Thank you, Anish. Yes, just mention case and then what's coming after. Exactly. So it's the hydroconductivity in the 3 dimensions. Did you finish this step? Let's type 4, specifically for the persons who were late, please. Thank you, Joan. I think we can stop, we can pass to the next part. So just to confirm that we said the hydraulic conductivity correctly, I said we can just go to this icon here for data visualization. We press, we keep color grids if you want, and then I go here. I have data sets. When I have my model result imported, I will have also results. I will press here, required, hydrology, and I press KX, for example. And I will have here difference of color for the values. You can try to do this if you want, and then we pass. Okay, we pass. Let's type 5 if you are ready to pass to the next part. We press 5 if it's okay. If you can see properly your hydraulic conductivity colors. No, actually, it's just to see the difference of if it's well said. If you have the same color, for example, for KX, but we set many values or different values, that means there is something wrong. It's just to visualization. We can do, for example, for KZ, because we had also 3 values, and we have also different colors, you see, for Nicola. Thank you. But for example, for KY, we will have this color because we have only one. And we come back only to none to have no colors. Yes, to the center, yes, you can just go to this here and it will be in the center. You see this one? For carry on. I'm sorry if I'm pronouncing the names in the wrong way. John. John, you press here, so it will be in the center. Is it okay, John? Thank you. Okay, great. So if you have any, let's say, kind of zoom or you can see your area, just press here and everything will be in the center. We can continue now, just to forget to set the initial head. I will come back to edit data set. And I will go to MODFLOW initial head. Its default value is model top. Let's go to model top -2, means under the model top by 2 meters. In the manual, it was mentioned +2, which is illogic. So just correct this, please. So while modeling our model, we can imagine that this water bottle is groundwater. We need to mention what's the initial level. Then, for example, I will drink from it. This will be the extraction and so on. So the initial head is so important. For example, if we will do or run our model on period from, let's say, 20 to 25 for the steady state. So the years 20 will be our initial head. Okay. And also in case of, let's say, more complex model or more realistic model, we'll insert them as a shapefile. A shapefile of piezometric level in the year 80 or our initial year. So we press apply to have our initial head and we continue. Just please correct its model top -2. Now we'll go to defining our boundary conditions. So we won't go through very complex boundary conditions. We'll go through constant head. Let's imagine that we have the sea as a boundary. We will set wells and we'll have a river, which is the basic, let's say, the basic packages that we can have. So in this case, because it's a very basic example, we'll use the tools of drawing. But I said usually we don't do this. Maybe in the next times we can do an example with some shape files and a more complex example. So I will go to this, to the line, or even this both can serve here. And I will draw a line from here to here. And please double click to finish the line. We'll have, once we finish the line and double click, we'll get this automatically this window. Are we going together? Let's type please 6 if we're doing the same thing. Thank you, John. So this is for setting or to input the constant boundary head. Thank you, Juliana. Thank you, Judy. The others, are you with us? Do you have any issues? Please, if you have any issue from the previous steps, let me know so we can fix and we can go all together. Okay, so I think I can continue. There is no questions. From our side on site, we have only 2 persons trying. It's like a group trial. Okay, that's great. So I said this is the inputs for the constant head boundary conditions. So we go to this. Once we have this window, it's just to define the parameters. Oops, yeah, we just skipped one part. But it's okay, we can do it in inverse way. So I will just name it CHD. Let me just come back quickly, sorry. We need first to check which packages we are using. So we'll go here. I'm sorry, I skipped this one by mistake. So I go to model and model packages and programs. I need first to check which packages I will be using before inputting them. Again, I will go to model, MODFLOW packages and programs, and I will have a window. That shows the packages. I will choose the 3 packages, CHD, River. Okay, so I will use this one for boundary conditions. We will check wells. And we can check river. If we have, in case we have a recharge, also we can import it as a shapefile. And we press OK. So when I do this, it's like that I activate these 3 packages. The others who are not checked are not activated. I will just go back to do the same thing I did before. I draw the line and we'll get, and as you can see here, because I checked the packages I will use, I will have them here. So I will name it CHD. We can give it a color if you want to change the color. For example, it's a line. Let's do it red. We keep that these boundaries are from the model top until the upper aquifer, because it's the sea is along this layers. And then we go here and we need to check again that this, let's say, item or this line or this shapefile, in case it's shapefile, is an input of CHD and not for the other packages. So we need to precise again, and I will press here. So here I will have the starting time as it's just one stress period for the steady state. I will add only one period. And then here for the starting head, sorry, we'll keep it model top. Or we can just mention it also as, let's keep it 0. Okay, we can add it 0. And we'll press OK. Can we type 6 in 6, 7, 8, sorry. Seven. Can we please? You mean, can you please remind me the MODFLOW packages and program option steps? What do you mean by program option steps? For the packages, it's okay. Or pass through.
When
You
we
mean
went to the packages and programs, were we supposed to select something before we went into the next step for the head, the CHD? It
Yeah.
was quite fast, so I don't know if you want
Yes, of course. Yeah, of course I can repeat. Thank you. So I said before inputting any packages, we have to select which one we use. So we go to model and we'll go to model packages and programs. Okay, to model, MODFLOW packages and programs, and then I will select which ones I will use. And by the way, even if you select 3, then later you want to use another ones, you can keep just checking them again. Like, for example, I check these 3, then I want to use another one. For example, I have a lake, so I can just go again and check the lake too. So you can add at any time a new package. Is it okay for Nicola? Can you
Yeah,
press, please?
that makes sense, but within the boundary conditions, were we supposed to tick the CHD time variant or not?
Are you supposed to take CHD or not?
Were we supposed to tick that on? Because like once we've ticked it, are we supposed to input any parameters or anything, or just say okay?
No.
No, okay.
Like when you do the opposite one, like we did in the beginning by mistake, you mean?
So when I first opened it, it was unticked, so I ticked it, but then I wasn't
Yeah.
sure if I was supposed to use the multiplier or if I was supposed to add parameters or anything like that. But it doesn't look like I need to.
So let me repeat slowly. So at the beginning when I just draw the line, but I didn't check the let's say the packages, it doesn't work. It's like I didn't do anything because the packages was not checked before. The step is that you need to check the packages, then you put the body, let's say the shapefile or the line. So even
Okay.
the first line that you draw doesn't mean anything for the model.
Okay. Yeah. Thank
Sorry,
you.
yeah, Nick. She will continue and you'll have to put in the parameters later. So you set up your objective properties, like the different packages that you want, and then you introduce the values later.
Okay, thank you.
The values for CHD I mentioned just 0, okay? There is no
Yeah, so she's setting a constant head boundary 0, eh? And the initial head is 0, eh?
yeah. No, the initial head was MODFLOW -2. Nicola, okay? The initial head was MODFLOW model top -2, and then the
Oh.
CHD was 0.
Okay, thank you.
Thank you. Okay, so this is for CHD. We can give it a value or we can go to 0. Then we go to the well. Also the wells, usually we have many wells in the area, but in our case we'll just mention one. For example, we put one here. You can put it in the same area if you want. So which item or icon I will use? This one, the dot one. And I will put it here. You can put it in the same area or in any other area. So when we press this and we go here, I will have also a window shown automatically. Sorry, my computer is a little bit taking time. So try to do it from your side, please. So we take this icon and we press here. When we press, we go also to MODFLOW features and we check well. Okay, this is what I have. I will name it well. So in this case, for example, I can keep it model top to upper aquifer, but in case you have, let's say the depth of your well, you can just set, for example, it's between the first layer and the second layer, so you can change the upper part or the upper layer here. You can change it, okay? Go to layers and you change them here. So I can have an, let's say, a well that is the extraction or the pumping is coming just between the model top and the middle aquifer, for example, or the model top and the upper aquifer. It's according the depth of your well and from which groundwater is pumping. In this case, let's take it like this, and I go to model features always here, and I will check well, because this data input is for the well packages. I keep always the same period, the steady state period. And here the, let's say the parameters I need is the pumping rate per unit, length or area. So we need the pumping rate for all the wells we mentioned. In this case, let's take it with, so as its extraction and pumping, we'll put the minus before the value. Let's go to this value. I'm just copying the values here in case you don't have the manual. This is the value. Sometimes in some areas like the arid areas, they also go for artificial recharge. So we can have some wells just for recharge. In this case, we can just put plus to mention that it's recharge. We can still use the well package, but with a plus to mention that it's recharge. And as it's not interpolated, it's the real value, let's say, I will just press here directed. If you are not sure about the value and it's interpolated, you can just go to calculated. And you press OK. Okay. Let's write, please, 8 if we are in the same step. Thank you, Nicola. What about the others? If you need that I repeat, please mention in the chat. For the teams that are working together, everything is going good? Do you need any help? Any question? So let's repeat. We said the constant head boundary condition. We said well. We still have the river now to mention. Great. So the river also generally it's a polyline, usually mentioned or insert or inputted as shapefile. And here we will draw it. So we can pick the same tool, straight line object or polyline object. And we can, for example, draw the river. Oops. Like this. Just use other tool. Let's use this one to don't have any, let's say, extra lines to other side. Always when you draw something, when export, even when we import, sorry, the shapefile will have this window automatically. We'll name this riv. It's the river package. So please, let's do this again. You go draw a line using this tool. This one. We draw a line which is supposed to be the river. And we'll have this window. So for this window is to set the parameters of the well package. I will continue. So for the river package, what do we need? Let's go first to check it. So I always go to MODFLOW features, and we check river package. Always the period is the same. What do we need now as input or as informations for the river package? So we need the stage, we need the conductance and the river bottom. I think someone was asking about the bathymetry, but generally we have to get it, not the MODFLOW will generate it. And in some cases we can, for example, link or just do the modeling the river in case you don't have any data, and then import the results to MODFLOW. But you have to mention this once. The MODFLOW won't generate them by itself. So we go to the stage. For example, we can go to the stage of model top -1 and -3. I will write for you the expression or the function. I go here. We can generally use interpolate for the river stage. So specifically it makes the, let's say, a difference in transient model where we will have generally a bigger, let's say, or longer period, and we have many changes and stress parameters. So go to interpolate, sorry, it's math. Yes, we go. So I will repeat functions always. I go to math and interpolate, and then we mention our, in case you have, let's say, the results from another model, or even, let's say, from measurement in the site of the river, you can just mention them directly as values. I mean, for example, it's just model top -1, and then the river bottom is model top -5, and so on. In this case, okay? So let's mention the by interpolation. The river stage, we say that it's fraction we press on F. We go to math to interpolate. And we can go to model top -1 and model top -3. Sorry, this is the top, so let's do -2. And then for the other one, for the bottom, we might mention a lower level. Be careful for the water or the level for the river, because generally mainly the errors are for the level, if he find the level above the groundwater. This is the function with the values. Please don't copy and interpolate, so you copy only the other values. Let's set it, and please write 9 before continuing with the other part. This is for the river parameters. So I will repeat, when you have your data for the river, you don't need to use the functions. You can just mention directly your values. Can we press or type 9, please? If you have an issue, just type also, write what you have as an issue in the chat. Any question? Yes, for river stage, exactly, John. Well, we just set river stage. We didn't set yet the bottom and the conductance. Nine, great. So for other participants, I'll confirm that this is the stage, the river stage. And then for the river bottom, it will be the same function, just we need to change values because it's the bottom, so it will be logically lower. So we go to the same function, just with different values. I will write river bottom. Others, is it okay? I will repeat this, okay? We're going through this, but I will repeat the river package. So once it's okay for the river stage, I can go to the river bottom. I go to math to interpolate, and I will do the same. And then we have the conductance value. Generally, it's calculated according to the type of the bed of your river. So, and the thickness generally. Let's take it 0050. It's calculated, okay? You need to calculate this according to the geology behind the geology of your river. The conductance is, all the values are mentioned for in the manual. Just for the river stage and the bottom, we change a little bit. Can we type 9? And if you want that I repeat, please type R. 9 if it's done, and R if you want that I repeat this step, please. Do we need to repeat? Is there any questions? Good, John. What about the others? I can repeat, guys. Yes, okay. So I will repeat this part. So first of all, I go to this. Okay, I will repeat for the others. So please try to follow me. So I go here. I will choose this tool and I will draw this line, which is considered as our river here. Okay, once I click or once I draw this, I will get automatically this window. You will have here objects, so you will name it as river. And we can keep this here as it is, but I said in case you have a well which is used for pumping only between 2 layers, for example, the first 2 layers, you have to change the bottom. And then we go to the MODFLOW features, and we have 3 parameters for the, besides the timing, we have 3 parameters for every river package that we use, which is the river stage, the conductance, and the river bottom. I repeat, in case you have the bathymetry data or the data of your river stages and bottom, you can just insert them as values directly. In our case, we'll try to interpolate using the function. So if this is empty or with 0 value, you just press on the F function, and we go not in dataset, we go to functions, and we go to maths, and we press on interpolate. We will have the word interpolate. Then you can copy this to the interpolation of the river in the cells. The interpolation equation is written already in the chat. I will repeat it. River stage. It's in the chat. Another one for the, so for the conductance, you will set this value 0050. And for the river bottom, it's the same thing. We'll use the function. The same function is interpolate. You press it, and here is the function for the bottom. It's in the chat again. Is it okay? I can repeat for the 3rd time, just for these packages. Do we need to repeat? Yes. Christmas, what's the point that you you are struggling with exactly. So I can go slowly.
Sorry, we just finished that part. So we can move
Ah,
forward.
Okay.
Okay, great. What about the others? Is it okay? Can we press
Others
9? Others? I can go ahead?
everything good, all good here.
Okay, so I will continue. In case there is any issue, stop me, please. Okay, so we set the 3 packages. All the parameters are done. Now we can try to run our model. Just did this. So how to run the model? We go to the small green link. We go here. We press again, we press here. This part. This is for running our model. So I will press it. When I say press, I will have a window just to save my model. So I can just name it model 1. I recommend that you put it in a folder, okay, not like randomly, because you have many files with it. So let's name it model 1. And we save it. I have a mistake here. It's okay, so the model is done, but I think this one is not worried. Let me check this. What about you? Is it okay? Oh, the pumping rate. How much was it? What about you? Let's press 10 if you have a smiley face and no error message. If you have an error message, let me know what is it. Is it working for you?
Okay.
Is it okay? Let's press 10. You have to get the...
Fatima, excuse me, you have a question here?
Yes? I can't hear you. I can't hear you correctly. Can you repeat, please?
Can you can you just go back to save the model?
I can't hear correctly.
I'm
Can
sorry.
can you
can
type,
you-
please? Can you come back to what? Come back to what?
Can you go back to how to save your model?
Yes.
Save to
Yes. Yes, of course.
because there's a popping error saying not from program locations.
Say what?
The saving of
So-
the model itself. How do you save it?
Yeah, okay. I will check
Oh,
this. Yeah, I will pass through again. So you go to run. Okay, listen. You go to run. Once you press to run, automatically you will go to a window where to save.
Okay.
Okay?
Message. Yeah.
And you just press yes.
Okay.
And if everything is good, you will get this one. And once Once we close it, we can have also the list folder. You see the LST extension are the results. So we can get down the budget. We can get down the balance of the water here, down in the folder with the extension point or 1.lst. For the others, do you have any? All good, great. What about the others? Let's press 10 if it's okay, and R if you want to repeat. So once we run the model, we'll get automatically the window to save it. Great, 10, good job. So once we have the results, we can get this. It will be opened automatically, and down we have the volume budget of the, for example, we have the in, what's going in our model, and the out. Okay. And for the steady state, we'll get, let's say, approximately of 0 because of the law of the mass conservation. Just in case you have many, let's say, many periods, the steady state and the transient, you will find many periods. So we'll just name here. You can check all the folder, okay? Now, once we get, great, so you have all 10. Now we get our data, our results, sorry, our model was running well. We will import our data to see that. So I will go here to File, Import, and I will import model results. I will repeat, to File, Import, and model results. Now what we have in our model is only the input. We need to import the outputs or the results that we got from running the model. So I will press on results, and I will go to the extension BHD, and I will mention open. Sorry, I forgot to change the language. Just it's open. And we open. Once we open, we click on open, we will get this window. This window is to mention which period I want to import its results. So for us, we have only one period, but in case we have many, for example, I go through a model of 10 years, and I want just to show the last 3 years. I will mention only this. I can't so separately show the results. So this is checked because it's the only one we have. We can get as results color grids or contour grids. Let's go for contour grids for the piezometric level or the head, or we can press neither. So I'll go to OK. And here I have the piezometric or the head lines. We can go, please just tell me or press 11 if you have the lines or the headlines, not necessarily as mine, because I'm not sure that you did all the lines like me. 11, great. If you didn't, which is logic that we don't draw the lines in the same place exactly, so we won't have the same lines, really the same like. So 11 if you have import the results correctly, and R if you want that I repeat. I will repeat correctly quickly. So I go to File, Import, Model Results, and I will press. The file I will import is the one with BHD extension. BHD. Once I have it, so I need to check the period. As in our example, we have only one period. It will be already checked. And then we have two options. We can import them as color grids or contour grids. We go to contour grids, and I mention OK. As I already imported mine, so when I press OK, he will tell me that the results are existing already. So I won't import them again. And this is what we have. In case, for example, I want to let's say see them, but let's say with a smaller difference between them, instead of 1 we go to equidistance of 5. I can just go here. Always the colorful one is to see the results or any kind of data I insert. I go here, so it's contour data. You see here the period water table. I can edit the contour interval. I'm not sure it accepts this because I've never tried this. No, it doesn't accept. So 1 is the smallest one. And if we go to 5, we won't see anything. But anyway, just keep knowing that we can change the interval contour or equidistance between the headlines. Until now, do we have any question? Actually, the process is the same. The process is the same, but normally we use the shape files. We import them. I say again, go to File, Import, and there's it. The most important thing that is to use the right projection for your, let's say, shape file when you just create your shapefile on GIS software, and when you import them and when you create the model here. So you need to choose the right coordinate or right projection. In case you don't choose the right, so you won't have, like, you won't see properly the inputs properly located. 11, can we pass? We have only one 11. What about the others? Do you have any question? Any issue? Okay, so this is the simple model. Now we'll pass showing you another more realistic model. So we can just pass through quickly, sorry. Give me just a few seconds to open it. So I go to model, and so you will find your history of models mentioned here. I will go to this one, for example. I press next. And it's opening. So for example, this is a more realistic model for case study in Algeria, in North Algeria. I will show you how we inserted the data really. So for the boundary conditions here, just for the area, I just create it in GIS and import it as a shapefile. I just go to here, import shapefile, and import it. So I choose the right, let's say, coordinate for Algeria, for North Algeria. For Fiji, we'll use for Fiji, and so on. Then for even for the river, I imported, and for the boundary, constant boundary head, it was the same. All was shapefiles. I didn't draw anything on MODFLOW or on Model Muse. How we insert them? So this was 0 because we have the sea here, Mediterranean Sea. For example, for the river, as we had the value for the river, so I mentioned all the values here, like model top mice and so on, you see, and the conductor. So we didn't use any kind of, let's say, equations or functions. And then we had the wells, also the wells. So remember, if I press here, means I will show all what I have as objects here. So I will click on wells, and these are the wells I have. So for every well, I have to input the pumping rate. Also, the wells are prepared from GIS shapefile and imported here. So once you prepare all your data, let's say we can say that preparing the data using GIS is, let's say, part or main part from conceptual model. So we need to set our data, we have the picture, the clear picture of our model, and then we prepare the data on GIS and then import them. This is what we do. So it's important to, let's say, have some knowledge using GIS. This is for wells. For example, if press the well, any well, we have a queue here, just I import it. Also, it was mentioned. So when I import the shapefile of the wells, I created a column called queue, and where there are the pumping rate. So I didn't need to mention them manually, let's say here, because I have a lot. I have a 140 well here. What I wanted to add also, so in the same way, for example, we go to, by the way, we have, for example, the recharge. The recharge, we can take it for the whole area, or if you have some zones that has, let's say, more or different rates of recharge, also we can do this using GIS. For example, let me just remove all this. We can, for example, separate it to areas. Every area has a recharge rate, different recharge rate. And then this is my model. When I want to import my data, I think they are here already. I go to contour, data sets, and optional I have the results, water table, and I have many periods because this is for the transient part. So I can, for example, set this one. I can mention a contour interval of 5, and I can get them like this. In this study also, we go to a future prediction, and mainly in our, let's say, study area or area, we have mainly the recharge coming from precipitation. So what we did is that we get the projected precipitation from CMIP6, the model, climate model, SMIP. We had 5, but the last one was 6, according to my knowledges. We get the precipitation, and in the area, the recharge from precipitation were estimated 20%. So we get 20% from the projected precipitation, and we add them. So we take, let's say, or we run provision or prediction in the future. This is how we can do, and we can get many maps always like this, and we compare with our observed data. This is for the steady state. Let me know if you have any issue for the modeling. If not, I came actually to the end of my presentation. Do you need that I repeat anything quickly before passing the speech or the mic to the host?
Okay. Hello.
Yeah, hello.
Yeah, Fatima. This is Christmas. Yeah, thank you.
Yes.
Thank you for your presentation and for guiding us to
Thank
the
you.
demo. It was really helpful.
Great, thank you.
We're really just right on time, like at 11:40. We are supposed to now take questions.
Yeah,
And yeah, I wonder about the online participants, whether there's some clarifications or comments, or even questions related to applications.
yes.
So shall we do it now? Nick, what do you think? Can I pass this to you? Then I'll also like collect. Oh, sure. Malakay here, one of the participants on site. He's just
Ah.
trying to write down his question.
Yes.
No
Over
worries.
to you, Nick.
Okay. Just while we're waiting for the questions to come through, can you hear me, Dr. Fatima?
Yes, I can hear you.
Yeah, thank you very much for that walkthrough and that tutorial. The sites that you had in your projects, where were
Yeah.
they from again? I was just curious, like where were the sites located?
It's in Algeria, in North Africa.
Yeah,
Yes.
okay. And these were they like confined aquifers or non-confined? What was the
No, it's unconfined aquifer, but it's heavily, let's say, affected by extraction last years. However, it's one of the main sources in the country. And in the semi-arid, let's say, countries, we have this issue of recharge. So the extraction became more than the recharge, which is an issue. So we go to the solution of seawater desalination. And it's actually also the problem in, let's say, the arid regions where I'm running a new study here in Qatar. So we need to deal with this issue.
Okay, thank you. Do we have some questions from the group here? I think we still have quite a few participants online. I'm just wondering. Okay. I'll read that out from Mr. Malakai. Can we model groundwater vulnerability contamination close to mining between two aquifer systems, confined and unconfined aquifers, using the PEST model?
I think I'll take that one.
Okay.
PEST is a calibration, eh? So you'll just use the MODFLOW 6, but if you want to run a specific calibration, then PEST. So PEST itself is not really a simulation model. It's just creating calibrated values for you.
Okay, thank you, Chris. Does that answer? Did you have any follow-up questions, Mr. Malakai? No. Okay. So, okay. Anyone else? Anesh, Selu, Juliana.
Sorry, Nick, there's another one on the agricultural use of package with MODFLOW and GSFLOW. We are using the USGS GUI model muse. GSFLOW, I think, is produced by Ontario or Vancouver. I'm not so sure, but I guess you can use it for agriculture use purposes. That's for Ronald Maharaj.
Okay, great. I'm not sure if the questions from the first half we had a chance to answer them yet, so maybe I'll just paste them in the chat again. I think they were partially answered, but I'm just gonna
No,
paste them.
Yeah, perhaps we haven't answered the bathymetry one.
Bathymetry.
Yeah, Farima, you can go with the bathymetry one, but from my end, you create the elevation and bathymetry at the same time. To me, for me, it's quite easy to do it with GIS and ArcGIS and QGIS. So you create the shape files ready before you input it into MODFLOW 6. Yeah,
For the
that'd be better.
bathymetry, for the river package, actually you cannot, it won't be, let's say, shapefile. The shapefile will be just to, let's say, mention the location of the river package. Then the data will be as an Excel more. Or sometimes you can combine with other, let's say, other softwares for modeling if you don't have the data. But if you have it, that it will be only a table added as data. But MODFLOW won't generate it I mean, by itself. You have to get this data by yourself. Or model it if you don't have it.
There are some more questions in the chat. I'm not sure if others are also adding further questions. please just type your questions, or you can try to turn on your microphone and voice them.
Yeah. Okay, can we do it this way? I think the question on the mineral related investigations is coming from our team. So, but there's another new question coming in. So I think if our resource person can give information or any response to that question. Fatima, would you, or Chris? Yeah, Chris, would you want to take that question? How would mineral related investigations such as mineral seepage can be done in MODFLOW?
Mineral seepage. I think you could do it as. I think you could do it as the same as contaminant flow. Yeah, we haven't done mineral seepage yet, but MODFLOW is also used for petroleum exploration. So if that is being done in Perth, I guess we could also do the same thing. Yeah, sorry about that. We haven't done any mineral seepage, but I think we can use it as a transport contamination, contaminant flow.
Thank you. We had a question from Tuvalu. How can MODFLOW be applied to simulate the freshwater lens in an atoll island, given the thin lens and high vulnerability to saltwater intrusion?
Yes,
This
this is a very basic, not basic, very common work done in the Pacific Islands. Probably not MODFLOW, but this is especially for Tuvalu, the Kiribati, Atoll Islands. This is a major objective. So yes, of course, you can use MODFLOW to do your own simulations. I think the government, Fiji, also the major objectives is estimating the thickness of lens, because you can, from that you can know how much extraction you need for your water resources management. Yeah, but yes, of course, this is one of the major objectives in the Pacific Islands. Yeah, estimating the lens thickness.
Okay, thank you. So before we just move on to the request from Mr. Anish Kumar, and this is really a good exercise to do, but can we just take up one more question? Here.
This one is clarification. You said MODFLOW to import shape files for DSMs. As I understand it, QGIS, ArcGIS, they do not produce DSMs in shape files. They produce it in image format. EMS, DSM or DTM, whatever you want to call it, EAS. So will MODFLOW support image files, or does it have to be shape files?
Chris, Fatima, let me go first, and then you can help me out with
Yes.
So your question is the format of the shape file.
Yes.
You can create your shape files work. There's a specific
shape files work. But normally when you create DSMs or DTMs using QGIS, the output is a image. Either TIFF or SRID or something like that.
So TIFF. TIFF works.
Okay.
Yeah. Yeah. You can add to it, Fatima.
Okay. So
Yeah. So just to clarify your questions, you are asking about the input or the output, like the results, if we can export them as shape files or images?
Input.
The input. So the input, we can actually add images, but the images won't be geo-referenced, let's say. Generally, we add them as a background. For example, if we want to see the land cover or some things like this. But mainly for the inputs, we have to put them as, let's say, a shape file, or for example, for digital elevation model, it would be a DEM or but the image, it will be an image. And you need, if you add it, you have to georeference it by yourself on the model.
Thank you.
Thank you.
Okay.
You also say don't lose money to some and the
Anish has kindly agreed to share some exercises. MODFLOW at a later stage. I'm not sure if you can do that through the best way for you to circulate to the whole group. Anish, if you want to maybe circulate through to us, and then we can email the people who registered. But another point, I think the last question was just around the surface water compatibility. Like there's Professor Jun said that there's a modular approach, so you can have different modules for different extensions and packages for surface water and other areas. So can you use HECRAS or SWOT or anything, or does it have to be specific software that's compatible? Like what's compatible, what's not compatible?
So I don't know, Jun Sensei, the variant, so the variant were older versions, so it's still compatible, but it still works. The older version still works. I know that I've seen some publication that SWOT and MODFLOW works. They're compatible.
Yeah, they are coupled. They can be coupled.
SWOT and
MODFLOW
MODFLOW are compatible.
with what? And even HECRAS with MODFLOW.
HECRAS is
Yeah.
compatible also.
Yeah.
So thank you very much. Look, I think that covers all our questions, and we are coming to a close. But I know that Pearl wanted me to ask if people who are comfortable, for whoever's comfortable to turn on their camera, we can do a photo of participants and everyone. We can do like a screen capture. So if everyone is happy to turn on their camera, we'll be able to see most of us. Okay, Selu.
Yeah, there's
John. Thank you, Professor John. Mr. Malakai. I know we had more than 20 participants or 30 people in the room, so now we're down to 27. And so I think there's still at least 10 that are very shy. But, that's it. If no one else is turning on their camera, I'll give everyone, and then I'll count us down. Merre. What about Delia? Tema? Okay, set. Oh, wait, good to see Emerosa and team up there. Aklesh. Okay. All right, everyone. Anesh. Okay. Okay. I'll count us down, maybe down from 5 to give everyone some time to turn on their cameras if they haven't already. Anesh. Okay, we'll say, yeah, we can say cheese. We could also say like activity, something like that, but I'll just probably cheese is better. Okay, 5, 4, 3, 2, 1, cheese.
Yes.
Set. Okay, set. I'll share that with everyone, that picture. That was everyone. I'm not sure, Christmas, Chris or Professor John, did any of you want to have any closing remarks? Or apart from, we just want to say thank you on behalf of the Oceania Geospatial Symposium, SPC, Linkage Project for participating in this. And a big thanks to the teachers, all of the teachers who took us through, Dr. Fatima, Dr. Chris, Christmas, and Professor John. I'm not sure if anyone else wants to add to that message.
Yes.
No, just
Oh, yeah.
thank you
Thank you
for
very much. We have a big contingent here, there were about 30 people interested, and this is good news for us because we are trying to build a foundation for our modeling for us Pacific Islanders. So I think we could be the pioneers of productive modeling in the South Pacific Islands. And we look forward to the next presentation in February or so, depending on Nicholas and Pearl's setup. And that one will be coding. So don't worry if you don't know anything about coding, we'll try and integrate AI into it. Okay, and see you again. Modemanda.
Pinaka.
See you.
Local level. Stay tuned.
All
Take
right.
care, everybody.
Thank you.
See you again. Thank you. Thanks everyone.
Thank you.
Thanks, Nick.